what conclusion, what difference did you come up with for the pair of the two graphs? What's their difference? It's the only thing that's different about them. Yeah, Marcus.
They're the same, but they're sort of flipped on the same vertex.
Okay, so it's flipped. So in terminology that we want to use, what should we say then? One of them opens up and the other opens down. Yeah, so they would you say the vertex is the same? Yes. Okay, so same vertex, but same shape as well. Same shape, but the first opens what direction? Down. And the second opens up. So looking at the equations, what part of the equation determines that? Yeah, the negative a value, right? So that's going to tell you if it's negative, it's going to open down. Okay, so what's the difference between the two graphs here? Wider. Second one is wider versus narrower? Yeah, so now is the shape the same? No. So now they do but how about the vertex? Same. Okay, so same vertex, but different shape. So the 2x squared is narrower, and we would call that a vertical stretch by 2, because it's vertically stretched by a factor of 2. And the 1/2 is wider because it had a vertical stretch by a factor of 1/2. So that VS is the vertical stretch. Okay. What's different about this next graph?
It's reflected across the y-axis.
Okay. Ooh, yeah, I like that. Reflected along the y-axis? Totally. Yeah, it is. Our x became a negative x is how we can say that, which you will in Math 30. So you would say it's reflected. So what changed then? What's different in terms of the terminology we've used yesterday? Yes. So now the first graph, so the shape is the same. We did not change the a value. We did not reflect it in the x-axis. But now we can say that the first graph has a vertex of 4, 3. And the second has a vertex of -4 and 3. So we just shifted it horizontally. We call that a horizontal translation. You can either call it a horizontal translation or it's reflected in the x-axis or y-axis. Okay, last graph. Shape, is it the same? Yes. Okay, good. Direction of openings the same. The first graph, what's different about it? Shorter? Yeah, okay, the vertex is different. So the shape's the same, so that we are only looking at a certain window. If we scroll up, it's going to be the same graph, right? Just shifted. It's just a vertically shifted and horizontally shifted. So what's the vertex on the first one? 4, 3, right? So our p-value is 4 and our q-value is 3. Remember, the p is the opposite sign of what you see there. And the second graph, the p-value would be +4, q is -3. So vertex is 4 and -3. And so it went through a vertical and horizontal shift. So we just moved it, right? We just translated it. Okay. All that investigation stuff was so long yesterday. I'm sorry. I'm going to change it for next time. Too long. So let's move on. I know a lot of you have to leave at 9:45. Is that right? Who has to leave? One. Oh. The rest of us will party. Or something. Okay. Wow. Lucky. Yeah?
When are we going to get a test back?
The trig one? Hopefully soon. I have a couple people that need to write. So. Oh, unless I just give them like a purely written. Anyways, therefore we can draw several conclusions. All right, let's draw some conclusions. What does A tell us? What does A do to the graph? Okay, opens up or down? Opens up if it's positive, opens down. It's negative. What else does it do? Changes the shape. Right? Because it's a vertical stretch, so it changes the shape because it's our vertical stretch. Okay, what does P tell us? What does P do? The x value for the vertex. Yeah, it tells us the x value for the vertex. So it's going to be a horizontal shift, and so the p value of the vertex, p is the x coordinate. It also tells us the axis of symmetry. Axis of symmetry is x equals to p. Okay, so if p is the x coordinate, q is the y coordinate. It's our vertical shift, right? Moves the graph up or down. And it'll tell us our max or min. So max or min at y equals q. So the maximum or the min value, depending on the direction of opening. So let's get to some math. All right, let's do this next one really quickly. Without using your calculator, we're going to sketch this. So the first thing we want to do is figure out what? The vertex. This is vertex form, so let's figure out the vertex. What is the vertex? Is it negative 1, 1? Good. 1 and 1. Remember the p value is the opposite sign. So because it's x minus p, so p is just the 1. So our vertex is at 1 and 1. Let's start there. Now, opening is going to be down. So we know we're going to opening down. And we know that its stretch is by a factor of 2. So remember that our pattern that we usually follow, 1 becomes 1, 2 is 4, 3 is 9, is now going to become 1 and 2, 2 and 8, 3 and I can multiply. So can I? I don't know. 18. Okay, so we're going to vertically stretch that. So what I mean by that is normally because we're going down, 1 to the left, 1 down is now going to be 2 down. 1 to the right and 1 down is now 2 down. Okay, does that make sense? No. Okay. So a regular x squared, if our a value was 1, we'd follow that pattern of 1 like this. So this would be our vertex. So 1 and 1 and 1. Okay, don't graph the red stuff. Okay, then 2 over would be now 4 down because 2 squared is 4. So 1, 2, 3, 4, and 4. Okay, so that would have been the regular if we didn't stretch it by a factor of 2. Because we're stretching it by a factor of 2, we have to double that pattern. Yeah.
Why is it stretching by
Because our A is 2. Yeah, so our A value is 2. Okay, so this is without using a graphing calculator. Now, will you have a graphing calculator with you during your exam? Yes, so you can check your work. But understanding this is very helpful. So that's why, if this was right, we're going to double this. So this was 4 away from here. Now we're going to be 8 away from our vertex. So another 4. Okay, because we're stretching it vertically. So our graph is actually the black one, not the red one. Oops. I was going to move it, but it didn't really move. No! Not you. Not you. Can I move? Oh, there you go. I don't want the red one. Okay. Now, you could use your graphing calculator. That's another way. So this was just me using the pattern. The other way is you can actually just make points. So you can make, this is the pattern method. The other way is you can actually make a table of values. Right? So you knew that your vertex was 1 and 1. So I'm going to, you know x was 1, y was 1. So now you do 2 and 3 and just sub it into the equation and solve for that value. So sub 2 in, negative 2 times 2 minus 1 squared. So we can actually sub it in. Negative 2, 2 minus 1 squared plus 1. So plugging your x's 2 in and actually getting that point. That's the other option if you're not using your graphing calculator. So 2 minus 1 is 1 squared. Negative 2 times 1 is negative 2 plus 1 is negative 1. So notice 2 and negative 1. There's that point. Okay. And we know it's symmetrical. The axis of symmetry is this line here. And so once you know one point on the axis of symmetry, you can just mirror it. You know the other one. I can plug in, solve for 3. It's another way we can do that if you don't like the pattern way. 3 minus 1 squared plus 1 equals what? Okay, 2 squared is 4, negative 8 plus 1, negative 7. Okay, and so there it is. 3 went to 3 and negative 7, and then I know that's a mirror, right? That's the axis of symmetry, so then I know this point here. So you can just make a table of values as well to help you out. Okay, let's get to the important stuff for today. If Blake has points 6 and 15 and 8 and 5 on the graph, let's plot those. So plot those 2 points. And oh shoot, do we have to change our scale? Okay, this is what we're going to do. We're just going to mark it off the graph. 10, 11, 12, 13, 14, 15, 16. Sorry, I should have gave you a better graph. Okay, 6 and 15, and then 8 and 5. Oh, 1, 2, 3, 4, 5. Okay. Okay. It says, and the axis of symmetry is at x equals 8. So let's draw that axis of symmetry. So if that's the axis of symmetry, and 8 and 5 goes through it, what does that mean about 8 and 5? It's your vertex. Okay. It also means that we also know another point, 10 and 15, because it's the axis of symmetry, right? It's symmetrical. So 10 and 15. going to be another point. Okay. What is the equation of the graph? So what we want to do is we want to use vertex form. Start off with vertex form. What do we know about this graph? We know what? It opens up. Good. A is going to be positive. What else? Someone told me. Do we know P and Q? Yeah, so let's start it by subbing in P and Q. Do we know our A value though? No. But we do know P and Q. So X minus P is 8 squared plus our Q is 5. Okay, so I have a problem. I don't know what A is. So we need to find it somehow. And that's where they give us another point, and we're going to use that other point. So to find A, sub in any other point. When I say other, any other point, just not the vertex. Because if you plug in the vertex, everything's just going to cancel and it's not going to help you out. So we need to plug in a point other than the vertex. So which point do we know that we want to plug in? 6 and 15. So I'm going to replace x with 6 and y with 15. And then I can solve for A. Okay, 6 minus 8, negative 2 squared. Negative 4, positive 4. Positive 4. So we want A by itself. First step is to subtract the 5. We have 10 equals 4A, and then 5 by 4 gives me 5 over 2, or 2.5. I like it as a fraction better. If you had it as a decimal, it's okay only if it's a terminating decimal. So if it's not a terminating decimal, it's a repeating decimal, then you need to leave it in fraction form for sure. Okay, so now we know our equation. There's our answer. Let's try one more like that. Find the equation of the parabola that has a vertex of 1 and negative 2 and goes through negative 1 and 12. Okay, right away, what do we know about 1 and negative 2? PQ. So we start with subbing in P and Q. So does it become x plus 1 or x minus 1? Minus 1, right? The formula is y equals, you can't see that, y equals ax squared, oops, nope, equals a times x minus p squared plus q. That's vertex form. Right, so minus p, or p is 1, so minus 1. And then minus 2, so q is a negative 2. Okay, what's my next step? Sub, yeah, sub negative 1 and 12 in to solve for A. So our y value is 12 and our x value is negative 1. Negative 1 minus 1 negative 2, and then square it is 4. Add 2. We get 14 equals 4A, or Divide by 4. 7 over 2. Y equals 7 over 2, x minus 1 squared minus 2. Okay. Do you want to try the next one on your own? Okay, give this one a shot. You try. Hint. Make your y-intercept into a point. Make me please. Okay, so that's the point you're subbing in. So when you do sub that in, you should get an a value of -2. So whenever we're trying to make the equation, our first step is to sub in our vertex. This next step is to sub in a point and solve for our a value. If the a is not given, you always have to solve for it. So you're going to have to go through this process. And then we can write our final answer. So there's our equation. Okay? And you can check your work. How you check your work is we can type this into our calculator, right? Graph it. Look at the table of values. Make sure it goes through those 2 points. If it goes through those 2 points, you know you have the right graph. Okay, so there is a way to check your answer. All right, last question. Yay! Everyone loves a good application question. So the toughest part of the next few days are the applications where you're given a problem and you have to make the equation. So it says bridges, arches, thrown objects. These are the types of problems that you might be given. So there's a tunnel. A parabolic tunnel has a width of 20 feet and a height of 16. So let's start by drawing that. Okay, so there's my parabolic tunnel. We know the width is 20. And it has a height of 16. We used to have a tunnel like this in Edmonton. They used to call it the rat hole. I don't know why they called it the rat hole. And they got rid of it. It was downtown. Anyways, write an equation to derive the cross-sectional shape. So there's a few options. Because it doesn't tell us where we want to put our origin. Right? It doesn't tell us where to put our axes and our origin. So it's really up to us where we put it. So one option is if we have the origin at the vertex. So let's do option 1. So origin at the vertex. Okay, so we're going to draw an axe, the axes. That's great. So we're going to draw a y-axis and an x-axis so that the origin is at the vertex. Okay, that's our point 0, 0. So now we have to figure out the other points. Let's look on the right side of the tunnel right now. We want to figure out this point right here. So if this is 20 feet wide, what's this distance here? 10. It's halfway. So it's 10. This would be 10. This would be -10. And then how low does it go to what? Y value? -16. Yeah, because it's 16 down. So this point here would be 10 and -16. And this one would be -10, -16. Okay. So when making our equation, the first thing we do is we put it into the vertex form. Plug in the P and Q. What is P and Q here? 0, 0. So if P and Q is 0 and 0, x minus 0 squared plus 0, how else could we write that equation? Y equals a times x minus 0. What's x minus 0? X. So x squared. And do you have to write plus 0? No. So that'd be y equals ax squared. How do we find a? Sub in a point, an x and a y. Which one do you want to use? Okay, let's sub in 10 and negative 16. So y is negative 16 and x is 10. So we square that, we get 100a. Divide both sides by 100, which let's just reduce our fraction. Can we reduce that? Oops. I think we can. I know we can, actually. So 8 over 50, 4 over, yeah, so 2 over 25?
4 over 5.
Oh, yeah. Thank you. So negative 4 over 25 equals 8. And so if our vertex is at the origin, then our equation is y equals negative 4 over 25 x squared. We're doing for 10. Okay. Now I'm going to have to, the textbook is going to ask you to make the equation multiple ways. So let's do one more method. Now the nice thing is once you have one, the others are really simple. Because is the shape of our parabola changing? No. Meaning our a value is still going to be the same. Because it's still the same shape. We're not changing the shape. And a tells us the shape of the graph and the direction of the opening. So now that we found a, the rest is easy. So now this time we're going to put our vertex at the edge. So the vertex, I mean the origin. Sorry. Origin at the edge. The vertex always works, so it doesn't change. Origin at the edge. So what we're going to do is we're going to have our y-axis here and our x-axis here, which is what a lot of you probably would have done in the first place. So our shape is still 20 feet wide and 16 high. Okay. So we need to figure out these 3 points. Well, we know this point over here is still, it's 0, 0, the origin. What's the one on the other x-intercept here? 20 and 0. And what's our vertex? 10 and 16. Good. 10 and 16, halfway. Okay. So we start by putting into vertex form. And this is the great thing, is do we know what our a value is? Yeah, we don't have to sub in a point and solve for it anymore because we know it. We know it's negative 4 over 25. Because the shape, doesn't matter where we put the origin, the shape of the graph is not changing. Once we know it for 1, it's the same. Doesn't matter where we put the origin. Okay, so a is negative 4 over 25, x minus what? Where's the vertex? 10 squared plus 16. Okay, there you go. So once you know your a value for 1, you know it for it all. Okay, now we're done. This is good. Gives a little time. So that's it for today's lesson. Basically the theme is making the equation in vertex form. If you don't know your a value, you have to sub in a point and solve for it. That's it. Okay? Good times? So the assignment is page 157 to 162, 4AB 6 to 9. 13 and 16 are optional. There are AP questions, so you don't have to do 13 and 16.